Welcome back. We're in Momentum, worksheet number 1. Last but not least, problem number 7. A 2-kilogram melon is balanced on a bald man's head. His son shoots a 50-gram arrow. Ooh, alarms go off in my head there when I see grams. Does it for you as well? And I go, oh man, I need to convert that into kilograms. Okay. So his son shoots a 50-gram arrow at it with a speed of 30 meters per second. The arrow passes through the melon. Whoa. And emerges with a speed of 18 meters per second. Find the speed of the melon as it flies off the man's head. Okay, so the melon is going to fly off the man's head. Interesting. All right, so let's identify our action. We should probably do that. His son shoots an arrow at that speed, so that is an action, but we're not looking at the change in speed necessarily of the arrow. We actually know that straight away, or the change of momentum of the arrow. But it says find the speed of the melon, so that's kind of the interesting bit there. And so I'm going to go ahead and use the arrow passes through. That's going to be my action that I'm going to be doing the before and after for, since I'm trying to figure out something about that melon there. Okay, so I guess in more and more complex ones, the finding that action becomes a little bit less trivial because we got to really look at some contextual clues there. All right, so a bald man's head. So here's a bald man's head, and he's not so sure about this. And there's a melon on top there. Okay, and now there's going to be a bow and arrow. So here's a bow with an arrow. The arrow kind of sticks through. No. Wait, hold on. See, I'm not even drawing this right. So the arrow sticks through, and then the feathers are like down there. Okay. So arrow shot. So that velocity of the arrow at the beginning is 30 meters per second. We know that the velocity of this melon here is 0. And since we're looking at the before and after of the arrow passing through there, we're kind of, it's shot at a speed of 30 meters per second, and we actually have to make a little approximation here, and we got to actually say that the arrow just before it goes through the melon there is actually going at 30 meters per second. So while that is a slight approximation, we're assuming it's the horizontal dimension there, and the horizontal dimension, it shouldn't be changing its velocity if we're excluding air resistance. So I guess it's the only approximation we're making there. Okay, so just before it hits the melon, it's going 30, and then afterwards, here's the guy, and he's going to be super relieved now. Yeah, because the arrow didn't hit him in the head. So now this melon, if the melon was to move, which way would it move? You'd probably say, oh, to the right there. Okay, so I'm going to move it to the right there. Here's the melon, and the arrow passed through there, so that's a lot bigger of an arrow. Here's the arrow that passed through, and the melon like broke open, so it like broke open there, and like splatter everything, and there'd be like a hole on this side now. Okay. So now we actually know the emerging speed. So the speed of this arrow at the end is 18 meters per second. The speed of this melon here, I'll put M for melon and A for arrow. Yep. Give him a neck there. All right, did I get everything in here? We'll get the mass here of the melon, mass of the melon. And this is the mass of the arrow. Oh, but let's go change that to kilograms. So I know that there's 1,000 grams in a kilogram. Kilo means 1,000, so I just take that and divide it by 1,000. I can do that in my head because that's 3 zeros on that 1,000, so I just move that decimal place over 3 times there, and I get a kilograms to be 0.05 kilograms for the mass of that arrow there. Okay. Emerges, find the speed of the melon after it flies off the man's head. So first I got to make my system here, and I can do it however I want, but I'm going to make it all the objects interacting here, which is the arrow and the melon. And if I do that, I'm including all the things that are interacting and changing, that are transferring motion, changing their momentum. So the change of momentum has to be 0. and that's the momentum of the beforehand has to be equal to the momentum afterwards. What's the momentum beforehand? What's the momentum of that arrow plus the momentum of that melon? And that's got to be equal, and these are befores. And that's got to be equal to the momentum of the arrow afterwards and the momentum of the melon afterwards. Well, do I know any of these things? Well, the melon, we said, is not moving at the beginning here. So this guy is big fat 0. And it looks like we're kind of guessing that both of them are going to be moving afterwards here. Okay, so it's the only one that's 0. Can I put in any values here? Well, this is the mass of the arrow times the velocity of the arrow at the beginning, mass of the arrow, velocity of the arrow at the end, and mass of the melon and the velocity of the melon at the end. So let's get one more line in here, and let's start putting in values. Mass of the arrow, we said is 0.05, and we know the arrow was going 30 meters per second. We know the mass of the arrow still at the end. We're assuming the arrow doesn't change in mass. Although, would it? Well, if it went through a melon, it'd probably pick up some of the mass from the melon. So there'd actually be a transfer of mass between that melon and the arrow. Interesting. Okay, we're not going to go that deep in this course here. So we'll assume that the masses are not changing. But still interesting nonetheless. Mass of the melon there. Wait, do we do? I think we knew, right? It's 2 kilograms of the mass of the melon. And then we don't know the velocity of the melon. So now, can I solve this? Hey, wait a second. I can just solve that straight away. So grab my calculator, and you grab your calculator and go to town on this calculation. So I got 0.3 meters per second for that melon. And it came out to be positive, I see there, and so let's go see if that makes sense or not. So one, it's going slow, 0.3 meters per second, and it's moving to the right. Well, yeah, that should make a little bit of sense. You said that the melon's probably going to be moving to the right. When the arrow goes into the melon, it would put a force on the melon going to the right there. Maybe I should show that. The melon here should get some sort of like force going to the right there. And so then it would start accelerating to the right or start speeding up to the right, you might say. But similarly, if that got a force on that, then the arrow then must have a force going the other way as well. And just from the last problem, we knew that that's Newton's third law right there. A, arrow, X on melon, melon, X on arrow. Those have to be the same amount of force there. So as one is speeding up, the other one, that's got a force going opposite of its motion there, so it's got to be slowing it down. And the arrow does slow down, as we would expect, and the melon then does speed up. Now, the melon has a lot more mass than that arrow there, so the arrow slows down, about half, 30 to 18, about half. So it slows down by 12 meters per second, and the melon only speeds up by 0.3 meters per second. Does that make sense? Well, it should, yeah, because that melon is so much more massive than this arrow here. So the melon will get going, but it's not going to be going as, it's not going to be an increase of velocity as great as the decrease of velocity of the arrow, because the arrow's so much lighter, you might say, or less massive. Okay, cool. But I think that was it. Did we need to solve for anything else? Find the speed of the melon after it flies off the man's head. That's it. Okay. Have a beautiful day. That's it for worksheet 1. Woo!